you can save the work and then go ahead to design our beams. So let's try to just go to our foundation beams right now. Go to design, go to foundation beams, and design your beams one after the other. Move the angle bar and put the bottom bar. This simplifies the design, and as you can see, the design is still okay and properly done. So we can keep doing that for each and every one of our designs. So we go, we select the third one, and then this is going to demand something special, so we need to change this to layer 2. Then add the top bar here, top bar 16. Then we need to take out all these 15. I don't want Y15, like the design error right there, and that's why sometimes it's always good to manually design your things. So now I'm going to take this to layer 2 as well. I'm going to add one here to take it to layer 2, and take this also to layer 2. And as you can see, as we keep adjusting these things, keep giving us the results that we need, eliminating all the red all the warning signs that it's giving us. Let's make this 16. Let's put it on layer 2. This is going to be 2. We're also going to put it on layer 2, and then it's okay. So you can go ahead to just check what it looks like, what the drawing detail looks like for this, because it's quite a little bit complex, and you can see what the drawing detail looks like. And you have 2y16 for the top, 2y16 for the bottom. Then you have this y16 for the bottom 2 right here, spanning from here to here. Then you have the bottom 2 again, 2y16 for the bottom. That's this bar is actually the bar that we introduced for the top, for the bottom, which is at the top kind of, and this one is for the bottom also, like below the other one at the support. And you can see that you still have 2y16 for the normal bottom still running, while the 2y16 for the top is also still running, and you have the 2y16 for the bottom also here at the support. You have all that 2y16 for the top still running, and then you have y16 for the bottom. So that's just like a very rough breakdown of what you have here. So it's not enough to just have this all well designed on. Having our design starters bring out the fact that our beams are okay. We can also go into our raft foundation analysis to check this, and let's try to do that right away. So we go here, we click on raft foundation mesh and analysis, and allow it to load up a little bit. And as you can see, it's generating can generate our model right away, and you can see that it's generated what the foundation model looks like. And you can go on to close this and allow it to load up again, and you can see that our subgrade coefficient is 50,000 kilonewton per meter cube. We are not really manipulating anything there. Then allowable stress of soil is 120 kilonewton per meter square, and what this foundation does really is that it optimizes the allowable stress of the soil, and into a level that the load coming upon it will not overwhelm the soil. In simple terms, optimizing this allowable stress of the soil in such a way whereby the load coming upon the soil will not overwhelm the soil. So let's go to analysis post-processing to see the result of our analysis. So you can see that we have our foundation drawn right here, and to effectively see if this allowable stress of our soil is not exceeded, we can go to soil pressure, click on soil pressure, then click on standard contours to check. I see that the highest pressure acting on our soil here is 60.778, whereas the allowable stress of the soil is 168 kilonewton per meter square. On this point where we click on, we can see that it's 27.3, 21.4. So as we keep changing position, it will be turning the value of the allowable stress of that particular area, and as long as it's less than our allowable stress, the one that has been optimized from 120 to 168, it says that the foundation is okay, and you can go on and proceed to carry out your structural detailing on this foundation. And the next thing to do now is to just close this and transfer slab strip FE analysis results. Transfer slab strip FE analysis results. Here we want to do that. Consider plate torsion effects with an hammer in slab design moment here. So we press OK, and it takes us back to our post analysis processing. Then you can transfer foundation beam results, use finite element method, and then you can close this. Then you have your design strip foundation, reinforced strip foundation right here, and sufficient for the load that is coming upon it. And you should also know that the more complex your structure, the more complex your design, until the level at a point in time when the foundation that is required for your structure is no longer a shallow foundation like this strip foundation. Because as far as we have, the soil stress program for this model is 120 kilonewton per meter squared. Anything that is below that may not really work for this particular design, which means you have to design what works for it. This brings us to the end of our tutorial for today on how to analyze a strip foundation using the FE raft foundation analysis. Don't forget to subscribe to our channel for more contents like this, and turn on your notification bell to be the first to see our latest tutorial videos on Protastructure and all things related to construction and architecture. Thanks for watching, and bye for now.